Okay, welcome back. I think I'm gonna take a shot in the dark here. My camera does not know how to focus. I don't know what the issue is. Hello? Are you okay? 'Cause you are spazzing out. Anyway, my camera is acting strange. So I might take a shot in the dark here, but I don't know if you've ever heard of this or remember this game. I don't remember what it's called, but it's a game where you have like these cars or something that you can only move them forward and back. You cannot. So for example, let's say I have car 0 and car 0 has to get to the end here. But car 1 is in the way. So car 1, let's say, is like right here. But then you have something like, you have car 2, which is like right here. So if I move car 2 like back here, then now I can move car 1, you know, out of the way a little bit. So that now I can move car 0 over here to the end. So there. I had to move some cars out of the way just to get the car that I wanted to the end. So what I want to do here is I kind of want to make this game-ish. I don't think I'm going to finish the game necessarily in this episode, but I'm also not going to create like the control for the game. Like, I'm not going to put a pre-programmed level in. What I kind of want to do is I want to try to kind of make an algorithm that we can almost, I guess we can watch the algorithm kind of happen. But I want to make like an algorithm basically where we have some cars that need to get, we want to create a puzzle automatically. So I want to make like a decent level, a game that we can play with cars like this, and I want to create it like automatically. Like I want to make some kind of algorithm to like make the puzzle for us, so that we have to solve it. But I want to watch it like get created from the solution backwards. Like I want to see how to do it if you can watch it carefully enough. But because I think that'll help us debug the algorithm as we make it. So I'm gonna call this CARPUZZ because it's like the car puzzle. We'll just call it the car puzzle. So this is gonna kind of be tricky for a couple reasons. One of the reasons why I think it's gonna be hard is we don't know. We can't just move the cars randomly necessarily. We kind of have to. I mean, we could if we wanted to, but we want to trap the car. And even though it might be easy to test, you know, if the car is trapped by something, it's kind of difficult to test that like recursive, like for the other cars too. And it's kind of hard to get it there in the first place, not just to test it, but to know like how far you need to move the other car to get it to be blocking this car. So I think it's like a tricky. I think there might be a way to do the algorithm, but I just don't know what it is yet. And so that kind of makes it fun. It kind of makes it a little, you know, scary, a little I don't know, a shot in the dark, but it's something at least we can try before I actually, you know, go try to research how to actually do this or something. But basically I want to start off with the car on like the right part of the screen. So I want the solution to be like the cars all the way on the right. And we'll just start, the length of the car is like I want to use L, but then I don't. We'll just say like 4 is the length of the car or something like that. Or we'll go with 3. Yeah, 3 will work. So 3 will be the length of the car. So I don't know. So I guess what I want to do, okay, so I guess the cars, the car will be in list 1 and list 2. So list 1, we're going to store the X's of the cars. Let's see here. Am I doing this right? Yeah, okay, so I think this is how I want to do it. So I want to store the cars in 2 ways. I want to store them as matrices. I guess, but also as lists. Because the list will store the actual card structure, its object, and then the matrices will store its where it will be intersected so that other cars can move. And I guess I'll start off the algorithm, even though there might be a better algorithm to kind of like move cars like partially. I want to start off by moving the cars like maybe like as far as they can be moved or something at first. So maybe for the main car on the right, I'm going to try to move it back the whole time, but I'm going to be moving the other cars to get out of its way, and then hopefully they'll move back in front of it or something like that. So I want to store, since it's going to be 3 long, this is difficult. So list 1, I guess, we'll keep all the vertical, or we'll keep track of whether it's vertical or not in list 1. So if it's positive, we'll put the coordinates in list 1 and 2, and then the length of it in list 3. So our x coordinate is going to be 16, 15, 14. So 14 for the x, and the y is going to be 4. And then, I'm sorry, I'm doing this all wrong. So 4 stores into that, and then this will be positive if it's horizontal and negative if it's vertical. So we're going to store 3, since 3 is going to be the length of it. Okay, so basically our car is stored in index 1. So So if I do a loop here, so I'm going to do a loop. Should I do a loop? I guess I could. Okay, so I could so I could do a loop through all the cars. Okay, so this is difficult. This is difficult. Basically, I want to display. Basically, I'm going to store this car onto a matrix. So I'm going to go through the loop. So I'm going to go for A is 1, 2, you know, the list of how many cars we have. So like, I'll say N. So right now, N is just 1. So we only have 1 car. Okay, so we're just starting off with car 1. But for all the cars, what we want to do is we want to we want B to go from 1 to the absolute value of list 3 of A. Which means we're going to go from 1 to the length of whatever vehicle, whatever car we're looking at currently. So right now we should just be looking at the first car, so it should be 1 to 3. Okay, so for each one of those we're going to take let's see here. Let's take list 3 of A and let's store it into C first. Okay, so let's do that. Let's do absolute value of C. So if C is positive, okay, so if C is greater than 0, because I want to do this fast. I want the algorithm to be kind of fast for this. So what I'm going to do is I'm going to actually split this into 2 different loops. Okay? And I'll do less than 0 since I already have the absolute value there. Okay. Okay, so I have 2 different for loops. One for if it's less than 0 and one for if it's greater than 0. Then I am going to output the vehicle. So let's go back up here and I'm going to clear the matrix A. So basically 8, 16 stores dimensions. of matrix A, and then fill it with 0. And then I'm going to store whatever car, or I'm going to store, I guess, just ones in where the car is supposed to be. So I'm going to store 1. If it's a vertical car, which it is here, then I'm going to store 1 from B. Excuse me. I'm going to store 1 into matrix A, and then the X, or the Y, then the X. So the Y is going to be list 1 Okay, so yeah, so list 1 is going to be X. Okay, so we're going to store 1 into Y, X, but we're going to add B minus 1 to whatever it is. So to Y, we're going to add B and then subtract 1. And then for here, we're going to do the same thing, except we're going to add to the X. And so what we're doing here is we're basically drawing the cars. So if this works the way I want it to, okay, I'm going to store A into that part of the matrix. So that way we can see what car's going on. So I'm going to output B, A, matrix A, B, A. Okay, oops. Where's CARPUZZ? Oh, and there we go. We have our car. So, that worked. Nice. Okay. So now what we want to do is we want to randomly fill up the screen with more cars. We'll leave the zeros in the background for now. Actually, no, we won't. We'll get rid of it. We'll take that and we'll store it into C or something. And then if C, then we output B comma A comma C. So there we go. We have our car on the right hand side. Okay, so yeah, okay, so now everything's programmed so that we can add in as many cars as we want. Oops. Did I put another A somewhere? This should be a 3, not an A. So yeah, if I want to basically fill the screen with cars if possible. So I'm going to come down here and I'm going to do a loop. I'm going to do a loop here. And I'm going to make it a big loop. It's going to be like a really long... Well, I don't know. So here we're going to display one. So I'm going to do an A is from 1 to, let's say 100. Okay, so it's going to be pretty long because I'm going to do a lot of calculations here. The first thing I'm going to do is I'm going to select a random integer from 1 to 15. And I'm going to store that as X. And then I'm going to select another random integer from 1 to 7. I'm going to store that as Y. Okay. Then I'm going to select a random integer from 2 to 5, and I'm going to store that as L for length. I'm not using L already, am I? Oop. Sorry about that. Keep bumping the camera. Yeah, so I'm going to check So let's see here. So I didn't really need that matrix creator thing because I actually need to be working with the matrices while I move around and create or delete cars. So actually that matrix down there, that loop, I probably will get rid of that because yeah, the cars can't just exist, and when I create them, I'm going to add them into the matrix anyway, so it's kind of like a pointless loop. So what I'm going to do is I'm going to check if my X plus hold on, I'm gonna say I'm gonna do a random integer from 0 to 1 to decide whether it's going to be vertical or not, and I'm going to say if random integer of 0 to 1, then negative L stores L. That way we have it facing the opposite way. And this is where I check to see if it's worthy of our n being incremented here. If it's worthy or not, we'll see. We'll see here. So we have to see if this car will fit in the screen for one. So first of all, if L is greater than 0, then we have two options there. L is greater than 0 or it's not. If it's greater than 0, then it's horizontal, I believe, yes. So if it's greater than 0, then it's horizontal. Then we check if x plus L, so if we start at 14, if we start at 15 and it's too long, so it could be 15, 16. Then it'll go off the screen if it's any longer than that. So if x plus L minus 1 is greater than 16, or we'll say less than or equal to 16, then we can do something here. Okay? And then if for here it's going to be y minus L minus 1 is less than or equal to 8, then we can do something with the y. Okay. Oh. So if it's less than or equal to 16, well, we can draw it basically. For B is 1 to L and we can draw it into the matrix. So, or you know what? Here, I got an idea. For now, let's just add it. So we can do n plus 1 stores n, and we can just store it into list 1, 2, and 3. So x stores list 1, y stores list 2, L stores list 3. Here the same thing. N plus 1 stores n. X, Y, and Z, or L, I'm sorry, store into list 1, list 2, list 3 of n. And we want to display n here just to see what we're at. So let's run CARPUZZ. So right now we have 10 cars, 15 cars, 20 cars. When it gets to 100, we'll see we'll see a lot of cars. Yeah. That's a lot of cars. and their numbers are too big. So what I'm gonna do to allow more than, you know, so many cars, and we're gonna check for intersection next. But those cars were just like overlaid without worrying about whether another car was there or not. So we'll work on that. But yeah, I think I'm gonna start wrapping this episode up just because this is gonna take a while and I'm new to creating this. But yeah, right now basically we just have something that just like basically draws a whole bunch of cars randomly onto the screen. I don't want to output C here. I want to output basically I want to store, well, what I'm going to do is I'm going to store a substring of string A. I mean a substring of I'm going to store that into string 1. That way we can have, well, that's not even 100 cars, is it? Yeah, so let's just go for, right now let's just go for 10 and try it. Okay, so there we go. We have 10 cars. Looks okay. Ooh, that one looks even better. So, yeah, 100 cars was a lot. But this looks like it's working out at least decently. The cars are stored in the matrix as well as stored individually. So we'll be able to test very easily whether we can draw a new car at a certain position or not. So this looks like it's nice. But yeah, I wanted to draw it. Oops. I wanted to draw according to the string, so I would use substring basically. But I can't really remember how to do that exactly. So I believe it's substring 1 C1 or something like that. Okay, so if I change this to like 20, it'll still work. We'll just have some A's and B's and G cars and stuff. So there we go. We didn't even properly lay out the cars yet, but that's it for